All right, everybody hear me all right? This is one of the first times in my life I need a speaker, I guess. I see some old students here from class. You probably know I can get rather loud, right? So, all right, thanks for being here today. My name's Kurt Steinke. I am the soil fertility specialist here at Michigan State. So lots of different things we're going to talk about here today. I got a whole punch list I put together last night. Probably 6, 7, 8 different things. Talk a little bit about nitrogen, a little bit about sulfur, a little bit about the weather. A little bit, we'll wrap session up. My graduate student Lane is here. She's going to talk a little bit about heavy metals in winter wheat production, whether that's something we need to be thinking about. If you haven't thought about it, get it on your radar because it is coming. All right, so we'll talk a little bit about that. But you know, one of the first things I want to talk about here this morning is what is the most common question or complaint we hear about wheat? Any idea? Price, exactly. I was thinking last night, you know, I've heard all winter and all spring, and you look at the last 5, 6, 7 years, probably the most common comment I get about wheat is I can't make money on wheat. Hands down. And my response to that, how much money are you making on 380 corn? Right? We think wheat has all these inputs. You know, Marty's going to talk about fungicides. Well, we have that on corn too. Right? Exactly. That's a whole nother story. But you start looking at the inputs. Are we choosing the right inputs? Are we choosing too many? That's a little bit of what we have to be thinking about. And the other thing we have to start thinking about, and I know Dennis has preached on this over the years, we got to think about planting date. But winter wheat management starts in the fall, right? It doesn't start first week in March. It starts in the fall. So a lot of what we've done the last couple of years is think about what nutrient practices can we do in the fall to capitalize on those spring weather conditions. Now, you've heard me over the years talk about weather variability, right? Now, how variable is the weather? You go back 2 months ago today, all right? What is today, June 16th? April 16th. All 83 counties in the state of Michigan had a flash flood watch or warning. First time in history that the state, every county in the state was under a flash flood watch or warning. And about a month after that, the drought monitor started popping up. Think about that. How do you capitalize on that variability? You start thinking about, did we have a cold spring this spring? I'd say by and large, probably, right? I looked at some weather data last night. Soil temperatures, at least in Lansing, crossed 50-degree threshold permanently on May 15th. 2025, they crossed the 50-degree threshold on June 3rd. Was it that cold this spring? Meh. But it was wet. Right? You're looking at 10 to 14 inches of rainfall from March 1st to about April 20th, give or take. That was the big driver, right? And that's really going to impact a lot of this, your end management program, your splits, things like that. So how can we capitalize on some of this variability? What is the biggest difference we see in autumn weather today that we haven't seen in previous years? Think about September, October, November. Late frost, in some cases no frost. And again, soils are staying warmer for a longer period of time, right? We're not dropping below 50 degrees here at this farm till about November 10th to the 15th. If you go prior to 2005, we would drop below 50 degrees about October 10th to the 15th. So you might think, oh, okay, so it's a month later. Look at that as an opportunity. Anybody that grows wheat, we have an opportunity in the fall to capitalize on a longer growing season. It might be you can plant a little bit later and still get that plant tillered. It might be We can utilize a little bit more nutrient management and actually get those nutrients into the plant, into the root, and into the plant in the fall, and not save it all for springtime. So one of those things we've worked on the last probably 3 to 5 years is looking at fall nutrient management practices. Right, and a little bit, obviously, could be nitrogen. So over the years, we've looked at fall N at a high and low rate, and you've heard me joke over the years. If I say 20 pounds, what's the grower apply? Probably 40 pounds. You got it. It's 2x. You get the gold star. And so one of the studies we started a couple years back is the some is good, more is better study. Right, and focus only on fall. Right, so we're looking at fall N, we're looking at fall sulfur, we're looking at fall P2O5, we're looking at fall K2O, we're looking at fall N and S combinations, and we're looking at fall NSP and a couple other micronutrients. And what's really stuck out over the last couple of years is the difference that sulfur can make in the fall. Right, so if you look at, one of the questions we often get is autumn sulfur versus spring sulfur. Which is better? Any idea? What's it going to depend on? Weather variability, right? And so what we've noticed over the last couple of years, we probably get about 3 to 5 bushel additional with fall sulfur as we do with spring sulfur. Now, will that be the case this year? I looked at the plots Monday. Probably not. Why? We haven't gotten 14 inches of rain in March and April in quite some time, right? And so sulfur, anion, flush that through the root zone. Fall applied probably does not look as good as spring applied this year. But one of the key things you have to think about is if you get that wheat planted on time, you have to have a root system to uptake whatever you do in the fall, right? So it all starts with that planting date. And we've looked at planting date studies over the years, and we've looked at fall nutrient management. And if you plant on time and get that nutrient into the plant, that plant is set up for better success and to capitalize on some of this environmental variability in the springtime as compared to a late planting or compared to applying that same nutrient in the springtime. So that's one of the things I want everybody to think about here. Is there something to do in the fall with that fall nutrient management? One of the best combinations we've seen, if you plan on time, that N and S combination in the fall has worked well. And we start thinking, we always get hung up on yield, yield, yield. If you look at some of the data over the last 2 years, our nitrogen use efficiency has increased about 5 to 12%, not by applying more nitrogen, but by applying sulfur, believe it or not. Right? So nitrogen and sulfur have this intimate relationship, ratio of about 10 to 1, ballpark figure 8 to 14 to 1. We use 10 to 1 as a good starting point. And if you don't have S, your N use efficiency can decrease. But some of the work we did the last couple of years has shown we actually get more N into the flag leaf by applying optimal amounts of sulfur than we do additional amounts of nitrogen. Right, so you start talking about every company you sell wheat to is looking for brownie points, sustainability points, all those measures. You can actually get more mileage out of your N by making sure you have sufficient sulfur as compared to 30 additional units of nitrogen. Now, how much sulfur is needed? Sulfur is not nitrogen. Right, that's one of the big take-home points. We're not looking at 125, 150 units of sulfur. What we've looked at over the years, again, about 25 units is all you need. All right, so it's not nitrogen, about 25 units. Single application usually does okay. If you applied it in the fall and we do have a wet winter, you might have to consider applying a little bit more of that sulfur in the springtime. So that's one of the items we've really worked on over the last couple of years. One of the other things, we always work on, one of the more common questions we get is, to make money on wheat, you got to have multiple split end application programs. What's that going to depend on? The weather, right? You tell me what the weather's going to be next spring, I'll tell you if you need 1, 2, or 3 N applications. Pretty simple. This year probably paid off. When I look back at all the split programs we've done over the years, it's usually about 20% of the time that split end can pay off. Some of that will depend on your yield potential, however. So one of the things we initiated this last growing season, we'll have more data on this winter, when we took the Yen UK trip last summer, I guess now, one of the things I noticed, over in the UK, they have 3, 4, 5 different N applications. But it's a much longer growing season. We forget about that, right? And it's a much more moderate growing environment. But what we started this year was looking at 1-step, 2-step, and 3-step N programs. All right, so over the course of the winter and fall, we'll share some of that data, looking at if you want to apply N just one time, what's the best product to use and when's the best timing to apply it. If you want to do a split N program, what are those best splits with a 2-split program, timing and product. And if you want to go whole hog and go a 3-split N program, what are the best products and timings to do that. Looking at how things look like so far, those 3 splits don't necessarily look better than 2 splits, and the 2 splits don't necessarily look better than the 1 split. Right? So that's something we'll talk a little bit more on. One of the other things I want to bring up here as you start talking about how the weather's changed, how wheat has changed over the years, how can we capitalize on that environment? Do we need to take a closer look at larger fall N applications? All right, you start looking at when that first 70-degree day is in springtime. That has varied by about 45 days the last 5 years. You look at when soil temperatures cross 50-degree threshold in springtime permanently. That has also varied by about 40 to 45 days the last 4 to 5 years. And so what we've looked at is how can we set that plan up in the fall to capitalize on that nice March and April weather. So one of the things we've looked at is some of these fall N applications, these bulk N applications, some with nitrification inhibitors, some without. Some have multiple combinations of that. And what we've noticed this year, we should have some fantastic data with some of this inhibitor data. 14 inches of rain in 6 weeks should put any product to the test of whether it's going to work or not with preventing leaching and denitrification losses. What I saw in the field thus far, some of that looks fantastic. Some of what we put down Thanksgiving week looks better than anything we put down at freeze up first week in March or green up first week in April. Right? And what does that tell you? You want to get that plant off to a good start, right? Start right to finish well. You want that plant tillered, and come springtime, you want that plant to take off, not working on tillering. And that's where some of this fall N management may come into play. A couple other things I want to touch on here. One of the big things I've seen this spring, and I've gotten pictures from probably all 4 corners of the state. For those of you that did have multiple split N application programs, after that second application, sulfur deficiency really showed up. I think I had a couple emails come in from all 4 corners of Michigan showing some really yellow wheat tops that mid to late April time period. And a lot of that was probably driven by, if you had sulfur in the system, the soil system, the heavy rainfall probably leached it out. And again, we talked about that N to S ratio. When you put that second N application on, that N to S ratio probably got too wide, and that's why that sulfur deficiency began to show up this year as compared to previous years. So that's one thing to keep an eye on. One of the other things I've seen a little bit more common is, has anybody seen dwarf or miniature wheat in the field? I've gotten a couple reports of this, and this is becoming a little bit more common probably the last 10 years, and a lot of that zinc deficiency, believe it or not. So if you see an area of a field where you have maybe 10, 12-inch wheat, right, you might think, the PGR you applied, maybe the boom was hanging a little bit too low, something like that. Oftentimes, take a look at that zinc soil test. What I've seen is some of those are zinc deficient, and there's a very, very narrow window when you start talking about zinc deficiency. At a pH of about 6.6, critical levels for zinc are about 2 parts per million. When that pH bumps from 6.6 to 7, that critical level goes from 2 to 7 parts per million. So about a 3-fold jump, right? And what you'll notice is you'll see a little bit of yellowing, you'll see a little bit striping, but you'll see these oddly shaped areas of wheat where it might be calf high or lower, right? And that has turned into be confirmed zinc deficiency in what we've seen better part of the last 5 to 10 years. The last thing I want to talk about a little bit is wet versus dry acres. Take a look. Do we manage them the same? Right? You start talking about yield maps, yield monitors, all the pretty graphs, and all the pretty colors we can get on these yield maps. What do we do with it? Right? Is it just based on nutrient management? Right? It is not. I think all of us here today know where water rolls to and where water rolls from in a field. And a lot of that is going to drive that yield potential. Right? We know where those areas are at in the field. So manage them a little bit differently. Those wet areas are the ones that you probably want to focus maybe that 10, 20, 25 additional units of nitrogen. And those dry areas, probably not. Right? Yes, we have drain tile. Thank the Lord that we do in a spring that we've had this last season. But take a look at those yield maps as you roll through the field this summer and try to correlate that with some of those wet and dry areas and tweak your nitrogen management and some of those other nutrients based on that also. The last thing before I hand it over to Lane is something that we started looking at probably, I'll say 4 years ago. We were approached by a company to start looking at heavy metal contamination of Michigan field crops. It's become a much larger issue overseas, especially in Europe, and it's become a much larger issue with baby food production. Because the margin of error in baby food is what? 0, right? It's something that we really hadn't looked at, but there's a lot of health issues that can be traced back to heavy metal and heavy metal consumption. And so Lane Saplito here, she's one of my PhD students, started looking at heavy metal contamination in wheat about 3 years ago now. And it's one of those topics, it's the white elephant in the room. When I go to grower meetings, everyone knows, yeah, it could be a problem, but nobody wants to talk about it. So we actually put a couple studies out and trying to address some of this. It's really interesting. I think it's really timely. Dennis sent us an article back in April that over in France, over half the population tested above threshold values for cadmium of the entire country. What do they eat a lot of in France? Baguettes and croissants, right? What goes into baguettes and croissants? Wheat, right? So they're actually proposing testing citizens' urine and blood for heavy metals to try to trace diets, to try to trace where they live. Some of this can be traced back to soil types and textures, but it's something that is on the radar, and some of it undoubtedly could actually come from the fertilizer that you are applying. Because what do we forget? Where do a lot of our fertilizers come from? They're mined, right? They're minerals. And what's in minerals? All sorts of different nutrients, including, in some cases, heavy metals. And so that's one thing Lane has started to look at is heavy metal contamination in winter wheat. So I'm going to hand it over to her, and she's going to talk a little bit, 5 minutes or so, on some of the findings that she has seen thus far.
Thank you, Dr. Steinke. So can everyone hear me okay? Awesome. Okay, so good morning, everyone. My name is Lane Beers. I'm a third-year PhD student, and now we're switching gears to food safety. So you've heard Dr. Steinke about fertilizer management to improve profitability, but now we're moving to food safety. So before I begin this talk, let me ask you one question first. Who do you think require more calories per pound of body weight? Infants and toddlers or adults? Okay, infants and toddlers? Thank you. Adults? Okay. Well, what if I told you that because of rapid development of infants and toddlers, they require more calories per pound of body weight. And what if I told you that the naturally occurring elements in the soil has become the closely monitored contaminants in baby food? And that's what we call heavy metals. I know you probably think of heavy metals as Metallica, who doesn't love them? But we're talking about the heavy metal here as the naturally occurring elements which have higher densities compared to water. I know you've heard of them, such as iron, manganese, nickel, copper. Sounds familiar, right? But there are other elements such as arsenic, cadmium, and lead that are potentially toxic at elevated concentrations. So you might ask me, hey, if this is naturally occurring in the soil, why are we just detecting this now? Well, the answer is science. Now more than ever, science is developing sophisticated methods to measure these potentially toxic elements at lower concentrations as low as parts per billion. Or let me use an analogy. A single drop of water in a 660,000 gallons of water, which is an equivalent in Olympic-sized pool. So if we can detect this in the soil, the question is, are we in danger? Well, not necessarily. I think the question we should be asking is, what are the mechanisms required for these elements to move into the crop? And if they move into the crop, the question we should be asking is how they move to the edible parts of the plant, which in our case, the grains. So for the past 3 years, we are conducting research to understand the mechanisms of how these potentially toxic elements move into our crop in a non-contaminated areas. I will repeat, non-contaminated agricultural fields. Are we clear? We're good. So the 3 studies we're conducting are first soil amendments. We're looking what are the potential soil amendments that can help immobilizing these potentially toxic elements into the crop, making sure they stay in the soil, or if they move into the plant, they move only to the parts we're not consuming. In this case, the biomass, not the grain. Second, slope trier. We are looking if how soil variability can influence the mobility of these potentially toxic elements into the grain. We know our field is variable, so chemical properties such as soil pH, soil organic matter can influence this mobility, and we want to understand that. And the last one is variety trial. We're looking if varieties can increase or decrease those potentially toxic elements moving into the grain. So before I end this talk, let me give you 3 main key points. First one, detection is not equal to danger. The mere detecting of these elements is not enough. You need to have a federally regulated threshold. Again, federally regulated threshold, which we will move to the next key point, is currently probably zero concentration is not the appropriate threshold. And the importance of having this ongoing communication with the government, the industry, and growers is critical to make sure that this threshold is feasible and not just out of the blue. Hey, I'm going to say 20 parts per billion. Where did you get that? Well, I guess. Is that feasible? I don't know. Do you have data? Maybe. Third one, understanding how these elements move into the crop is more important than by just detecting it from the soil. Again, we are consuming grains. We are not consuming soil. We're not consuming biomass. We're consuming grains. And by understanding how these potentially toxic elements move into the grain is more important than that. And with that, thank you so much for listening. And if you have questions, we're here.
Any questions? Yes, sir.
About the forage being fed to cattle, is it going to go into the cattle?
The question was about, are you referring to metals then, I assume? Yeah. So the question was about heavy metal contamination in forage. Can it go into cattle? Yes, absolutely. Kind of a related but unrelated topic. We're also looking at PFAS contamination across the state too, and that's one of the ways it got into the human food chain was through feeding contaminated forage to cattle. So yes, that could be a possibility. But again, our whole philosophy here is how can we mitigate some of these areas that may be high? And the other thing to think about here is we've noticed over the years, we sample everything in spring. It might not be an issue. And then come August, all of a sudden, a certain heavy metal will spike for some reason we do not know. So areas that were not above threshold end up above threshold. Areas that were above threshold sometimes end up below threshold by the time we get to mid-season. That's why Lane's doing some of the environmental variability, looking at some of these rainfall factors, slope, soil texture, things like that. Good question. Yes, sir.
Is there heavy metals in the fertilizer we're applying? If so, what's being done about that?
The question was, are there heavy metals in some of the fertilizer that we are applying? And if so, what can or is being done about that? We have seen in some cases, yes, because you have to remember when you get outside of our end fertilizers, you start talking about some of the P2O5 products, some of the K2O products out there. Those are mined products. They're mined from the earth, right? And earth has different minerals, different mineralogies, and in some cases there are heavy metals in some of those products. That would be one thing that internationally they're starting to take a look at. There's some movement over in Europe trying to establish some of these heavy metal thresholds on some of our more popular fertilizer products. I have not seen that carry over yet to the domestic U.S., but we can also say there's other regulatory actions that happen overseas that end up carrying over to the domestic U.S. So it could be a matter of time, but they are starting to take a look at that. Yes, absolutely. Yes.
We've been tracking the heavy metal content of our soils on a broad range, like through Michigan and through the United States. And are they increasing because we are using commercial fertilizer application?
You want to respond?
Okay, so the question is if we're looking at the U.S. soils and if it increase or decrease based on the fertilizer amendments, currently there is no data in the U.S. fields. We are investigating background soils. When we say background soils, this is not artificially contaminated. This is just what's in the soil. And currently there is no available data in the U.S. And we are still doing this project. We started it in 2024, so currently we have 3-year data that we're still working on.
And it's important to note we're not looking at contaminated sites, right? We're not looking at old mining areas. We're not looking at old orchard ground where some of those chemicals that were used in the 50s and 60s had heavy metal active ingredients, right? We're looking at straightforward, conventional agricultural fields that happen to be high in some heavy metals. So that's our real focus here. We want to get some data to establish thresholds so that if regulatory action is taken, that they don't just pull a number out of thin air.
Is there a possibility there will be different standards for where we can sell wheat and somebody might want to buy it and somebody else won't want to buy it?
That could be a possibility over time. You know, they're looking at different standards for root and tuber crops that are grown in the ground versus crops that grow above the ground. Could there be regional standards? Possibly, because again, there are different soils across the U.S. and some are naturally higher and some are naturally lower in that heavy metal concentration. Anything else?
What about sludge?
Question was about sludge. Yes, they are looking at biosolid application. That has been fairly well known due to heavy metal contamination over time. We know it's in the human food chain, so obviously it is in biosolids. So that is something to think about. Sydney.
Sulfur. Are Michigan soils naturally deficient in sulfur, or is this an over, you're kind of amping it up?
So the question was, are Michigan soils naturally deficient in sulfur, or is it naturally occurring over time? We've seen the sulfur response increase over time, right? Deposition from the atmosphere has been cut by 80-90%. Fertilizers are a lot more pure today than they were in the 70s and 80s, so there's less sulfur along for the ride. A little bit increase in some no-till production, so we see that S response increase also. What we've seen in some of these upper Midwest states is sulfur has been applied so much that in some cases we're seeing non-responsive sites. In Michigan, that isn't as much of an issue. That S response has become more common. It's become more common on your N responsive crops. Do we see it in soybeans? Periodically, yes. 2024 was a great sulfur year in soybeans. We saw about a 10 to 12 bushel increase because July and August were so wet. Typically, we get that best sulfur response on your corn and wheat acres, and oftentimes that sulfur you apply to corn and wheat can carry over to those rotation crops, including soybean many times. Not always. It's going to depend on what? The weather. Yes. Yep, the question was about different forms of sulfur. So over the last about 5 years, we've compared AMS, we've compared ATS, we've compared gypsum, we've compared some of the proprietary products, the MES10s, MESEs, things like that. They've all performed pretty similar. When we look at fall applications of S, some of the more proprietary products that have elemental S and sulfate sulfur tend to do a little bit better, because that's what they're intended for. They're intended for a longer sulfur window versus some of the more soluble products. So, the bigger thing is make sure you get it on versus maybe in some cases looking at that source. See where you get the best deal, right? Some questions always come up with regards to solubility. The solubility amongst all those sources that I mentioned are pretty similar. Right, you're splitting hairs when you talk about something being 87% soluble versus something that's 85.5% soluble. You'd have to have the stars and the moon would have to align perfectly for you to see a response based on that difference in solubility. So the bigger question is, again, get it on. When is the best time? Fall can be a great time if you plant on time. And I emphasize that. If you do not plant on time in fall, and some of that's not under our control, maybe beans aren't coming off, maybe it's a not so great fall, and you have to plant wheat late, we tend not to see that response with that fall application. Even when we look at some of our other fall nutrient management, it only occurs when we plant on time, because you have to have that established root system to uptake whatever you apply. Anything else? What's the right time to plant? So you start looking at through the thumb and through the south central part of the state, you're probably looking at that Hessian fly-free window still applies. You start looking at probably September 18th, 19th to about October 3rd to the 5th. That covers a large percentage of our acreage. When we get outside of that, we've looked at fall nutrient management with September 20th planted wheat and fall nutrient management with October 10th planted wheat. That October 10th planted wheat did not respond. You have to get that plant in the ground early and get it established and get that root system established. Good question. So I think I'll wrap it up there. I'll hand it over here to Jeff.
Okay, thank you.